everyone, this is Teacher Abby, and for today's video, we're going to talk about arithmetic series. For the objective of today's lesson, we need to define arithmetic series, find the sum of the first n terms of a given arithmetic sequence, and solve word problems involving arithmetic series. Before we proceed in our discussion, let us first solve this problem. A building has 5 floors in total. 20 people live on the first floor of the building, 34 people on the second floor, 48 people on the third floor, and 62 and 76 people are living on the fourth and fifth floor respectively. How many people in total are living in the building? For us to find the total people living in the building, we just add the numbers of the people living in each floor. So we have on the first floor, we have 20. On the second floor, we have 34. On the third floor, we have 48. On the fourth floor, we have 62. And on the fifth floor, we have 76 people. So we just add all of them. The total value or the total people living in the building will be 240 persons. The problem that we had a while ago is very related to our today's lesson, which is about arithmetic series. By definition, it is the sum of the terms in arithmetic sequence. Example, if we had an arithmetic sequence which is 2, 4, 6, 8, and 10, the corresponding arithmetic series for that would be 2 plus 4 plus 6 plus 8 plus 10. You just simply add the terms in order for us to get the arithmetic series. Example number 2, if we had an arithmetic sequence which is negative 8, negative 3, 2, and 7, we just simply add negative 8 plus 3, negative 3 plus 2 plus 7 in order for us to get the value of our arithmetic series. And now let us evaluate a series. In evaluating a series, we just simply add up the values. Example, if we had an arithmetic sequence which is 2, 11, 20, 29, 38, and 47. In order for us to get the value of our arithmetic series, we just add up the values or the terms 2 plus 11 plus 20 plus 29 plus 38 plus 47. That would be equal to 147. Now, my question is, what if we have a large number of arithmetic sequence? Is it still possible for us to add up the values manually? If we do have large number of terms of an arithmetic sequence, it is very impractical for us to add up the terms manually in order for us to get the values of our arithmetic series. Now, since that is impractical, this is the time that we should use the formula in getting the value of arithmetic series. In arithmetic series, we have two kinds of formula. The first one would be the sum of an infinite arithmetic series. If we're going to get the sum of an infinite arithmetic series, we simply had the formula S sub n is equal to n over 2 times 2 times a sub 1 plus n minus 1 multiplied by d, wherein S sub n will be the sum of all the terms or the value of our arithmetic series. N is the number of terms. A sub 1 is the first term. And D would be the common difference. And now, let us have an example. For number 1, the sum of the first 16 terms of the sequence 1, 7, 13, and 19 is what? So the first thing that we should do is to get the values of the given. So our a sub 1 would be 1 for the first term. D would be 6, since 7 minus 1 is 6. And 13 minus 7 is 6. Also, 19 minus 13 is 6. So, the common difference, or D, would be 6. Our N would be equal to 16, since we are looking for the sum of the first 16 terms. So, based on that given, we're going to get the value of our arithmetic series, which is S sub n is equal to n over 2 multiplied by 2 times a sub 1 plus n minus 1 multiplied by d. As you notice, we have an infinite sequence here because we doesn't end up to 19. We end up to the 16th term of the sequence. So using the formula, we just substitute our given. So that will be S sub 16 equal to 16 over 2 times 2 times 1 plus 16 minus 1 multiplied by 6. In here, we just simplify first the ones that are inside our parentheses. So that will be 16 minus 1, which is equal to 15. Okay, so from there, again, we can simplify them by multiplying the parentheses with the numbers outside of it. That would be 2 times 1, which is 2. 15 times 6, that would be 90. Then, we can simplify 2 plus 90, that would be 92. Then, from there, we can simplify 16 divided by 2, that will be 8. Then, we're going to multiply 8 times 92, which is equal to 736, which is the sum of the first 16 terms of the sequence 1, 7, 13, and 19. So, 736 is the value of our arithmetic series. Let's have an example involving word problems. In a classroom of 40 students, each student counts off by 4s. Example, the first student would count 4, the second student would have 8, the third would have 12, and the fourth would have 16, and so on and so forth. What is the sum of the students' numbers? So, again, let us first identify the givens. The given would be, our a sub 1 would be 4. Since we start off by 4. Then, our D is equal to 4 since we're counting off by 4s. Then, our N would be equal to 40 since we have 40 students in the classroom. Now, let us get the value by using again the formula of getting an arithmetic series of an infinite arithmetic sequence. So, as you notice, this is an infinite arithmetic sequence since we do not know the last term. So substituting again the given values to the formula, that would be S sub 40 is equal to 40 over 2 times 2 times 4 plus 40 minus 1 multiplied by 4. So the first thing that we should simplify is 40 minus 1, which is 39. Then, in this case, we should multiply 2 times 4 and 39 times 4, which is both equal to 8 and 156 respectively. 8 coming from 2 times 4 and 156 coming from 39 times 4. So, simplifying 8 plus 156, that would be 164. And 40 divided by 2, that would be 20. Then 20 times 164, that would be 3,280. So the total, or the sum of the students' numbers, would be 3,280. Let us have another example. The sum of the first 15 terms of an arithmetic sequence is 765. If the first term is 23, what is the common difference? First, let us get the given. So, we had there a sub 1, which is 23, since that is our first term. We had also n equal to 15, since we have the sum of the first 15 terms. And our S sub 15 will be 765, since we have the value already of the arithmetic series. Now, we're going to look for the common difference. And as you notice, this is again an infinite arithmetic series, since we do not know the last term. Okay? So, substituting the values to the formula, so that would be 765 equal to 15 over 2 times 2 times 23 plus 15 minus 1 multiplied by d. So, let us simplify first. 15 minus 1, that will be 14. Then, let us multiply 2 times 23 and 14 times d. 2 times 23, that will be 46. And 14 times d, that will be 14d. So, since we cannot simplify or add 46 with 14d, let us simplify first 15 divided by 2. That is 7.5. But in order for us not to get a decimal point in our answer, we just simply eliminate 2 at the bottom or the denominator. For us to remove the denominator 2, we just simply multiply 2 in both sides. So, we just multiply 2 from here. Here. Then, from here. So, 2 will be cancelled out. Then, 2 times 765, that would be 1,530. And the term that will be left behind on the right side would be 15 times 46 plus 14b. In this case, we can simplify the terms in the right side by distributing 15 each on the term each side. So, 15 times 46, then 15 times 14d, which will have 15 times 46, which is 690, and 15 times 14d, that will be 210d. Then, for us to get the value of d, let us transpose 690 to the other side. Since this is positive, that will be 15 1,530 minus 690 equal to 210D. Then simplifying 1,530 minus 690 would be 840 equal to 210D. So in order for us to get D, let us divide both sides by 210. So this will be cancelled out, leaving D behind. So 840 divided by 210, that will be 4. So our common difference will be 4. Since we are done with the sum of an infinite arithmetic series, now we're going to have the sum of a finite arithmetic series. So in this one, you're going to have a finite arithmetic sequence. What do you mean by finite or finite arithmetic sequence? It means we do have the last term. We know the value of the last term. Okay? So using the formula, that would be S sub n is equal to n over 2 times a sub 1 plus a sub n, wherein S sub n is the sum of all the terms or the value of the arithmetic series, n is the number of terms, a sub 1 is the first term, and a sub n would be the last term. And now, let us have examples. So for number 1, find the sum of the first 15 terms of the arithmetic sequence if the first term is 11 and the 15th term is 109. So let us get the givens. So the given for a sub 1 is 11, since that is our first term. Our a sub 15 or last term is 109, since that is the 15th term. And our n would be 15, since we're looking for the sum of the first 15 terms. So as you notice, in this example, we do have the values of the last term. Since we have the values of the last term, this arithmetic sequence is a finite arithmetic sequence. So, since it is finite, we do use the formula S sub n is equal to n over 2 times a sub 1 plus a sub n. Substituting the values from the given, that would be 15 S sub 15 over 15 over 2 times 11 plus 109. So, let us simplify first the operation inside the parenthesis, which is 11 plus 109. That would be 120. Then simplifying 15 divided by 2, that would be 7.5. Then 7.5 times 120, that would be 900. So the sum of our first 15 terms would be 900. Okay? For example number 2, we do have find the sum of the first 20 natural numbers. So, what is the first natural numbers, by the way? The first 20 natural numbers would be numbers starting from 1 up to 20. So, based on this, let us have the given. So, the given would be a sub 1 would be 1, since we are starting from 1 up to 20. Then, a sub 20 or the last term would be 20. And n would be 20, since we're looking for the first 20 natural numbers. So, since we all know the first term and last term, let us go use again the formula S sub n is equal to n over 2 times a sub 1 plus a sub n. Substituting the given, that would be S sub 20 equal to 20 over 2 times 1 plus 20. Simplifying 1 plus 20, that would be 21. Then 20 divided by 2 times 21, that would be 20 over 2, which is 10, times 21, that would be 210. So the sum of the first 20 natural numbers is 210. In our last example, let us evaluate the series for 6, 8, 10 up to 50. So the given would be a sub 1 equal to 4 since that is the first term. A sub n is 50 since we're looking for the last term which is 50. The d is equal to 2 since 6 minus 4 is 2, 8 minus 6 is 2, then 10 minus 8 is 2. So, let us use first the formula a sub n is equal to a sub 1 plus n minus 1 multiplied by d. Since we do not have the values for n, let us get first the values of n using the formula of the arithmetic sequence. So, substituting the values, that will be 50 is equal to 4 plus n minus 1 multiplied by 2. In this case, we're going to distribute 2 to n and negative 1 or minus 1 rather, since we cannot simplify n minus 1. So, 2 times n, that will be 2n. 2 times negative 1, that is negative 2. So, that is why we have 2n minus 2. Then, from here, we can simplify 4 minus 2, which is 2. Then, plus 2n. Since we cannot simplify 2 plus 2n, we're going to transpose the value of 2 to the other side in order for us to isolate 2n. So, since this is positive 2, transposing to the other side, that will be 50 minus 2 equal to 2n. 50 minus 2 is 48 equal to 2n. Then, divide both sides by 2 since that is the number beside n. So, this will be cancelled out. So, the value would be n. And 48 divided by 2, that is 24. So, that is the value for our n. But we're looking for the value of the arithmetic series. So, since we already know the first term and the last term, we can use the finite arithmetic series formula. So, that is S sub n is equal to n over 2 times a sub 1 plus a sub n. So, a while ago, we cannot directly proceed to this formula since we do not have the value of n. So, we get first the value of n using the formula of the arithmetic sequence. Okay? So, that would be S sub 24 equal to 24 over 2 times a sub 1, which is 4, times plus rather a sub n, or the last term, which is 50. 4 plus 50, that is 54. Then, simplify 24 divided by 2, that is 12. And 12 times 54, that is 648. So, the value of the sum of this sequence for up to 50 is 648. And since we're done with our examples, we're going to have your activity. And this activity, you're going to find the arithmetic series or the sum of the following. Starting from number 1, that is 5, 12, 19, 26 up to its 16th term. Number 2, that is negative 21, negative 16, negative 11 up to its 50th term. Number 3, what is the sum of the first 100 positive odd integers? 4, the sum or the arithmetic series of 3, 6, 9 up to 63. Then 5, the sum of 320, 324, 328 up to 4,820. So that's all for today. Thank you for watching. If you have questions, you can message me via Facebook Messenger, Abby Mendoza. Goodbye!